Cobb-Douglas Factor Demand functions. For example, if the production function is Cobb-Douglas, Q equals capital A times capital L to the power A, and then multiply by capital K to the power B, then equations 15.10 and 15.11 are P times A times capital L to the power A minus 1 multiplied by K to the power B equals W. And P multiplied by B multiplied by capital A multiplied by capital L to the power A multiplied by capital K to the power B minus 1 equals R. Solving these equations for capital L and capital K, labor and capital, we find that factor demand functions are capital L equals open parentheses A over W close parentheses to the power of open parentheses 1 minus B close parentheses over D. Then we multiply that by open parentheses B over R close parentheses to the power B over D. Then we multiply that by open parentheses capital A times P close parentheses to the power 1 over D. That's equation 15.12. Capital K, capital, equals open parentheses A over W close parentheses to the power A over D multiplied by open parentheses B over R close parentheses to the power open parentheses 1 minus A close parentheses over D multiplied by open parentheses capital A times P close parentheses to the power 1 over D. Equation 15.13. Where D equals 1 minus A minus B superscript 3, which reads, if the Cobb-Douglas production function has constant returns to scale, D equals 0, then equations 15.12 and 15.13 are not helpful. The problem with constant returns to scale is that a competitive firm does not care how much it produces and hence how many inputs it uses, as long as the market price and input prices are consistent with zero profit. By differentiating the input demand equations 15.12 and 15.13, we can show that the demand for each factor decreases with respect to its own factor price, W or R, and increases with P. Given the parameters for the estimated long-run labor demand equation 15.12 is capital L equals open parentheses 0.6 over W close parentheses to the power 4 or is that a superscript 4? I believe it's to the power 4. Then we multiply that by open parentheses 0.2 over R close parentheses multiplied by P to the power of 5. And the long run capital demand equation 15.13 is capital K equals open parentheses 0.6 over W close parentheses to the power 3. open parentheses 0.2 over R, close parentheses, to the second power. And we multiply that by P to the power 5. The shares of its total revenue that a competitive firm pays to labor and to capital do not vary with factor or output prices if the firm has a Cobb-Douglas production function. Q equals capital A times capital L to the power A. We'll multiply that by capital K to the power B. A competitive firm with a Cobb-Douglas production function pays its labor the value of the marginal product. W wage equals price times the marginal product of labor, which equals A times P times capital A times capital L to the power A minus 1. Multiply that by capital K to the power B equals A times P times Q over capital L. As a result, the share of the firm's revenue that it pays to labor is a weird looking W to the power capital L equals W times capital L over open parentheses P times Q close parentheses equals A. Similarly, this weird looking W subscript capital K equals R times capital K over open parentheses P times Q equals B. Solved problem 3.7 makes a similar point about the properties of the Cobb-Douglas utility functions. This with a Cobb-Douglas production function, the payment shares to labor and capital are fixed and independent of prices.